Hi, my name is Ben, and I am a technical director at a creative digital agency here in Portland called Instrument. And my team goes by the name Labs, and we tend to work on projects that bridge the digital and physical realms. And we did one last September called Duet, and I'm going to talk through that really fast now. So Music Fest Northwest, that is a one-week music festival here in Portland where hundreds of bands come and play at venues all over the city. And we thought it was a cool opportunity where we could possibly bring Music Fest together with the people of Portland through a public interactive installation. So our idea was to create this field of illuminated structures, and each structure would represent a single music venue. And the lights in these structures would be controlled both by the music happening at those venues, but also by the general public through a mobile web app they could use on site. So we tested a lot of different materials and lights, and we came up with this design for the structures. It's a tetrahedron. We had this idea for lights running down each leg, but the problem is that there is no illuminated tetrahedrons aisle at the hardware store, so we had some work to do to make these things real. So the legs are made from anodized extruded aluminum. The corner brackets and other hardware were laser cut from steel and powder coated to match. And even though the structures are all different sizes, luckily all of the hardware could be common because the angles are all the same at the corners. So for the lighting, we used a flexible RGB LED strip. And unlike the corner brackets, all of the leg lengths were different. So we had a whole lot of measuring and cutting and like hundreds of solder joints to deal with. But it worked. And so to drive these LED strips, we use a system called Pixel Pusher, and it runs over Ethernet, and it has a really simple software interface. And so we were able to use that to drive the 6,348 LEDs and have precise control over every single one and still run the whole thing around 30 frames per second. So it's pretty sweet. So during this process, I was coding like a madman, and the software piece is split up into sort of a tiered architecture. We've got pieces running out in the cloud, we've got the stuff that runs on the phone, and then stuff running on site on a computer. So for the performance side, we wanted to have live feeds from all the venues, but it just wasn't logistically possible after we looked into it. And so instead, we took one track from each artist, pre-analyzed the tracks, and came up with like 2.5 million time-coded data points. That's all of them. And so for the mobile side, for visitors to the site, we created a mobile application that allowed them to directly interact with these structures. And it would send all the data in near real time using WebSockets up to our server, which was out in the cloud somewhere. I think we used Amazon AWS or something like that. And it was running on Node.js, which is a nice JavaScript-based server architecture. And so it would take all of that interaction data and also notifications from Instagram and Twitter, send that down to the control app that was running on site, and it would also text message me if anything went wrong at the installation site. So at the installation site, we had the control app running on a computer. We just shoved a Mac Mini and a bunch of networking gear into a box, strapped it on a telephone pole, and magically nobody messed with it for a week. So the control application also had a very detailed knowledge of the physical layout of these structures, and so we could use effects like down to the pixel level. We knew where they were. We could make effects that actually had spatial relevance. So when people would draw on the little map on the mobile app, like streaks of light would shoot through the whole thing. It's pretty cool. So leading up to the day of the install, we tried to pre-assemble as much as we could, and so we put the legs together, the structures, and then we tested everything at each stage of the process, which saved a lot of troubleshooting headache later. So we loaded everything onto a flatbed truck, and we took it to the installation site. I had this little printed schematic of the site, sort of like a reverse treasure map. I staked out all the center points, then we laid a whole lot of cable, and we finished a few hours early. So then we're waiting for the sun to go down. The software is running. All I could do was sit back and hope that I hadn't written some really gnarly bugs into my scheduling and playback systems. But when the first band started playing in Music Fest, the whole thing came alive, and people were dancing inside these things. It was awesome. So I was exhausted, went home, and went to sleep. And then my text messaging system let me know that something was wrong. We had one of those late fall Portland monsoons, and the circuit breakers had tripped, and we lost a couple of LED strips, but it was a quick fix, and in the end, it worked out great. So with projects like this, I keep finding that there's rarely a tool for the job that already exists, and so a lot of my job is tool making. And this time, I focused heavily around this idea of a central data file that controlled the layout, and so I built all my tools around this one single point. And that let me work on individual pieces, knowing that at the end, it would all line up. And it really did. So here's some 3D renderings that we did early on in the process and photos of the actual installation. And you can see they're pretty dang close. So that's the project. You can see more about it on Instrument's website. And we've got video of it moving, which is really cool. And then you can see other stuff we're up to at Instrument/Labs. And then you can also find me there. Thanks.